Hypothalamus Artificial Intelligence Incorporated and GAMS, General Algebraic Modeling Systems Incorporated present. Mathematical programming in the aviation industry. Success cases. HI is a company at the forefront of high-performance artificial intelligence. Hypothalamus Artificial Intelligence, HAI, and General Algebraic Modeling Systems, GAMS, have agreed on a technology alliance to jointly provide services to the special transport sectors, based on highly complex mathematical models. The technological capabilities of the two companies, in artificial intelligence and mathematical programming, make them ideal partners to face the multiple challenges that exist in advanced analytics applied to the transport sector. Due to the experience of the two companies, this alliance is particularly strong for the optimization of special transport systems such as the aviation industry, planning and operation of ports, and rail systems. HI-GAMS is the strongest alliance in mathematical programming, due to HI's ability to model complex systems, and GAMS's ability to produce tools for mathematical programming. Mathematical programming in the transportation industry. Optimization-based applications cover industries and mathematical problems in all sectors. The table, developed by IBM, presents the most familiar applications in several sectors. The travel and transport sector stands out. The table presents some examples of optimization cases in the aviation industry. The table presents some examples of optimization cases in the railway industry. The table presents some examples of optimization cases in the port industry. Aviation industry. Mathematical models cover the entire hierarchical chain of decisions, strategy, tactics and operations. Below are real-world use cases, along the decision-making chain, across the multiple subsectors that make up the aviation industry. Multimodal transportation industry. The air cargo industry typically includes as part of its operations, the distribution of goods by land, using multimodal transport systems. Federal Express. Since 1973, FedEx uses all kinds of mathematical models to simulate and plan operations, finances, resource use, personnel allocation, route structure, which has allowed an evident growth of the company. In 1997, FedEx was the first company in express transport services in the world. Average income of $16 trillion a year. FedEx had presence in 211 countries around the world, 45,000 vehicles, 662 aircraft, and 7,800 service centers worldwide. More than 3.3 million of packages per day. Frederick Smith, CEO and founder of FedEx, said, "Operations research was applied effectively in FedEx, and reversed the 4-hub serial design decision in favor of a single superhub. It saved the company." United Parcel Service, UPS. The largest shipping company in the world, and one of the first to provide logistics and transportation services. With presence in more than 200 countries and revenues of more than $50 billion per year. UPS, in addition to providing logistics and transportation services, it is an important consultant and developer of software tools aimed at the optimization of the supply chain. UPS uses operations research to design your network of shipping services, solve and optimize load handling problems, operations planning, expansion planning, and management decision making. DHL is a world leader in express air transport, with a presence in more than 220 countries, and more than 70,000 employees. DHL also offers cargo transport, warehousing and other logistics services. DHL develops and provides consulting in the implementation of software tools, aimed at optimizing the supply chain. DHL uses operations research to design your service network, improve customer service performance, increase service coverage, improve service reliability, general decision-making in the workforce, and redesign of the service network. Optimized workforce management. Airlines face itinerary disruptions, flight delays, and daily cancellations due to unexpected events, including inclement weather, mechanical problems with aircraft, and unavailability of flight crews. As a result, crews may find themselves in the situation of not attending their scheduled flights. Airlines must quickly reassign crews to cover available flights, and return them to their original schedules, in a cost-efficient manner, while meeting government regulations, contractual obligations, and quality of life requirements. The main problems in workforce management: staff sizing regulation, rostering, timetabling, task assignment, and monitoring and control. Lufthansa. In 2003, the running time of the monthly crew planning process was manual, and took about 7 weeks. The last step, the crew assignment, took about 2 weeks. Time to market from fleet assignment to actual flight was from 7 to 11 weeks. The challenge was to find the balance between company requirements and individual interests. The goals the system for crew assignment were: the time to market must be shortened significantly, and the crew assignment step must be automated and shortened. The ACA, Automatic Crew Assignment, was introduced as kind of plug-in to the Crew Assignment Editor CAS. ACA transforms the crew assignment problem into a mathematical problem. The benefits of the project were: better rosters in shorter times, hours versus days. Duty rosters generated in a more effective, responsive and cost-sensitive way, and very good user acceptance. Southwest Airlines uses mathematical modeling to increase performance and speed of crew scheduling systems. The application leads to on-time performance and more accommodating schedules for crews. Enables the airline to create a daily crew schedule from between 36 and 48 hours to about 7 to 10 hours. Mathematical models can create schedules, which causes crews to stay closer to home, while traveling fewer days, and spending less time idle at airports. Air New Zealand Limited, a domestic and international airline, that provides passenger and cargo services, needed to improve the way it scheduled shifts and equipment. The challenge was 2 problems: planning of minimum cost work shifts, sequences of work and rest periods, to cover all scheduled flights, and formation of teams to assign shifts to individual members of a crew. Solving these problems would require expertise in mathematical programming. Between 1986 and 1999, Air New Zealand staff and consultants, in collaboration with the University of Auckland, developed 8 optimization systems to solve all aspects of the airline's shift and equipment planning in its domestic and international operational processes. Since 2000, these models have saved approximately $12 million per year, while providing shift assignments that better respect crew members' preferences. Continental Airlines. Caleb Technologies, working with Continental, developed the Crew Solver Decision Support System to generate globally optimal, or almost optimal crew scheduling, rescheduling and assignment solutions. Continental estimates that in 2001, the Crew Solver system helped save approximately $40 million in just major outages. And thanks to the system, Continental led the American airline industry in recovery of operations after September 1, 2001. Since then, 5 airlines have implemented similar systems to reschedule aircraft, pilots, and crews after an outage. In Pan American Air World Airways, staff scheduling optimization decreased in man-hours, in small airports 6.5%, in large 11%. Effective use of available resources frees the time on engineers. Optimized fleet management. The main problems in optimized fleet management are: fleet planning, minimize capital-intensive assets; fleet scheduling, routing, rescheduling, and minimize operational cost; fleet tracking, track fleet, and reroute, recover from disruption; freight tracking, customer information, and freight routing. Optimal airplane seat layout. Each airplane has a limited space which can be allocated to first class, business class and economy seats and others. Some factors will influence the decisions regarding the optimal seat layout as follows: the ticket price for each seating category is different, the number of demand for each seating category is subject to uncertainty, and space occupied by each seat type. For example, first-class seats will need more space compared to economy seats. Vueling airlines. Re-optimization of planning timetables. Vueling needs to adjust the planned flights, this due to multiple reasons of force majeure. Route replanning must respect certain business rules. Cisneria developed Daedalus, a suite of tools aimed to assist airlines and improve their planning processes and operations management. Daedalus comprises 3 different modules: Rotations Builder, Tail Assigner, and Operations Manager. These modules can be used as standalone tools, or work interrelated, to cover a wide variety of planning and operation stages. Vueling is already using Daedalus. United Airlines developed SOA, System Operations Advisor. Between October 1993 and March 1994, SOA saved more than 27,000 minutes of potential waiting. SOA has allowed United to respond to problems in a timely manner that was not possible before. It demonstrates how operations research can be used effectively in the airline operational environment. Revenue management in aviation industry. The Sabre story history, the making of operations research magic at American Airlines. It is the result of the success of operations research in the industrial environment. If necessity is the mother of invention, then deregulation of the airline market is the father, and revenue management, also known as yield management, is the couple's golden child. The relationship between American, Sabre and operations research is as robust and complex as the models and problems they tackle every day, but most of all, it's a richly rewarding relationship for all concerned. AMR, the parent of American Airlines, and step-parent of Sabre Decision Technologies, provided a nourishing home in which soared to unprecedented heights in terms of impact on American, on the entire airline industry, and on a good chunk of the rest of the corporate world. Fueled by constantly improving forecasting and optimization models fed by more and better data, each new generation produced in excess of $100 million in incremental profitability over its predecessor. By 1998, Cook estimates the revenue management system at American Airlines was generating nearly $1 billion in annual incremental revenue. To put that figure into perspective, consider that the airline's total operating profit didn't approach $1 billion until 1997. Today, virtually every airline in the world employs some sort of revenue management system. The concept is also hard at work throughout the cruise, hotel and car rental industries, and wherever else you find perishable, limited capacity. Optimized terminal management in the airport industry. The main problems in airport planification are capacity planning, ground holding, allocation and scheduling of aircraft in land waiting, and design the exit gate system. Scheduling of activities, allocation of exit gates, baggage claims, and programming landing and takeoff tracks. The main problems in optimized terminal management are strategic planning, size resources, and evaluate design. Tactical planning, check feasibility, and pre-assign resources. Scheduling, final schedule. Control, execute, update, reschedule, and see bottlenecks. Schiphol Airport uses mathematical programming to design of network transportation between terminals. To avoid traffic congestion, a transportation system below ground, with automatically guided vehicles, AGVs, was developed around Schiphol Airport. It is unique in its scale, incorporating 25 km tubes connecting 20 terminals, with 400 AGVs, to carry 3.5 million tons of cargo. To schedule this operation used solutions of mathematical optimization, which includes location of AGVs between terminals, terminal programming, and traffic control. Paris Airports carries out the planning and programming of the list of ground personnel using the Maxime system based on artificial intelligence. Maxime program, approximately 1,000 employees in the 2 airports of Paris. The system is composed of rostering, IATA season, weekly scheduling, daily task allocation, D-Day allocation and reporting. The rostering module generates legal rosters in less than 1 minute. Staff productivity was increased by 30 to 75%. The LIST module was used as a simulation tool to negotiate new labor regulations with unions. Paris Airports optimizes allocation of airport gates, stands, belts and other resources using SIGA, a decision support system based on operations research. SIGA is composed of scheduling of resources, the day before operation, and real-time allocation during day of operations. The system uses optimization for automatic scheduling, and a log visualization technology for interactive Gantt charts. Benefits of SIGA. Operators manage a 10% growth in traffic, in each terminal, with the same quality of service, and ensures fair gates allocation to all airlines. HACTAL, the resource management of Hong Kong Airport Air Cargo Terminal is based on RMS, an online advanced scheduling system, to cater for the changes in flight schedule, and resources availability. RMS creates schedules for allocating resources such as personnel, docking bays and transport equipment. Constraints include flight arrival and departure times, shipment sizes and destinations, and safety and transportation regulations. The benefits are airplanes are loaded or unloaded rapidly, and the system cuts waste in time and storage. Military aviation industry. Military operations research is embodied in countless solutions to specific real military problems, which support the planning and scheduling of many of the military forces of multiple countries. It can be said that the use of operations research, in military planning, is a very powerful tool, to optimize the use of its force in search of peace. The ADANS, Airlift Deployment Analysis System, is a clear manifestation of the importance of operations research in modern warfare such as the Persian Gulf conflict, which was planned based on two operations. Desert Shield, before operations, and 2. Desert Storm, war operations. The scale of the logistical effort required to deploy coalition forces in Saudi Arabia, prior to Operation Desert Storm, required the harmonious and coordinated mobilization of air, naval, and land forces from 33 countries, nearly 1 million troops, 200 ships, 2,400 aircraft, 2,000 helicopters and nearly 3,000 tanks. During the first 75 days of Operation Desert Shield, the U.S. Military Airlift Command, MAC, with the help of the Crisis Action Group, mobilized 155,000 tons of equipment and 164,000 troops across the nearly 13,000 kilometers between the United States and Saudi Arabia. To schedule the mobilization, the MAC commander used the Analysis Group, AG, formed in 1986 to provide analytical support to the operations of the MAC, composed of 24 operations research analysts. ADANS saved in the order of $280,000 per air mission. Phoenix is an optimization model for modernizing the Army's helicopter fleet, that is based on a mixed linear programming model. Phoenix optimizes annual costs of operation, maintenance, retirement, extension of service and provision, respecting fleet age restrictions, technology mix, composition, and multi-annual budgets. In 1987 find the optimal mix of new and repowered aircraft for more than 7,000 helicopters. Phoenix considers the minimum and maximum levels of operational aircraft, minimum fraction of highly technical aircraft, average maximum age, maximum and minimum capacities of the production line, maximum and minimum levels of production per year and availability of aircraft as raw material for renewal. Until 1991, the U.S. Army had applied Phoenix to a fleet of 335,000 land vehicles. Warner Robins Air Logistics. The process of repairing and mobilizing the giant C-5 Galaxy military cargo plane is extremely complex and expensive. Routine maintenance of a C-5 takes between 40,000 and 50,000 man-hours. Working time per aircraft averaged 240 days. Despite recent productivity gains at the Warner Robins Air Logistics Center, about 10% of the Air Force's fleet of C-5 aircraft was under maintenance there at any given time. At a time of high demand due to the Iraq War, Warner Robins needed to accelerate the pace and efficiency of maintenance to maintain a high proportion of C-5 in service while facing Air Force budgetary pressures. The C5 line employs about 24 supervisors and 460 mechanics, organized by skill groups, and enlisted for routine maintenance, or for considerable repairs to the C5 fleet. In 2005, Warner Robins decided to use operation research to gain efficiency in the complex task of repairing multiple C5s simultaneously. The implementation of optimization models reduced the number of C5s under maintenance by 38%, from 13 to 8, in just 5 months. Maintenance time was also reduced by 33%, from 240 to 160 days. The economic benefits of this productivity increase are projected at $75 million. Non-economic benefits include a high speed of response and reduced loss of life in times of war. Aeronautical sector planning. Given the complexity of air operations and the need to ensure the safety and comfort of passengers, the planning of the aeronautical sector is decisive for the quality of life of people. Federal Aviation Administration of the United States of America, FAA. The FAA has a significant responsibility for handling the arrival and departure volumes of flights from all U.S. airports. Sometimes airports are forced to reduce their arrival capacity and suffer congestion when they cannot keep up with the demand imposed by arriving planes. In these cases, the FAA uses the Ground Delay Program Enhancement (GDPE) to delay flights before they depart from their home airports, keeping traffic at a level acceptable to the affected airport. Solving this problem required the expertise of mathematical programming to model numerous flights and arrivals through the complex system. The mathematical model places arrival quotas at aircraft and airports during periods where demand exceeds capacity. Decision makers at the FAA and airlines use the GDPE to keep congestion at an acceptable level by alerting aircraft before their departure. The GDPE significantly reduced delays, improved air traffic flow compliance with schedules, and the quality of information and its predictability. From January 1998 to January 2000, nearly 90,000 hours of delays were avoided due to GDPE, resulting in savings of more than $150 million for the airline industry. After the attacks of September 11, 2001, airport security increased dramatically. However, high security meant a very high cost for the airline industry, and for the comfort and efficiency of serving the traveling public. While the need to increase safety was not in dispute, the civil aviation industry wanted to ensure that new safety measures were implemented with maximum effectiveness, without causing undue expense and disruption. Industrial engineering and operations research professionals from Boeing and the Transportation Security Administration, TSA, developed a suite known as USCAP's economic tool, that employs probabilistic simulation, queuing theory, and linear and nonlinear programming. The models analyzed, over a horizon of more than 20 years, the macro order of magnitude and the operational and economic relationships of the key elements in the North American commercial aviation system. These models help define and predict the operational and economic impacts of aviation safety options for all of North America. In particular, the tool helps decision makers estimate safety efficiency, review customer service performance, and assess the economic and business impacts of different policies, strategies, and operational alternatives. Cost and benefit values are calculated for the TSA, as well as for airlines, airports, hotels, and related services. For example, TSA decided to include all workers in the sector in the passenger verification process, and made other technological and business decisions, which hope to reduce the total number of verifications by 7%. The TSA also hopes to do a better job of prioritizing certain verification actions to optimize total investments, resulting in an estimated $2.5 to $3 trillion in savings for airlines. It is also believed that regulatory decisions resulting from the economic model have prevented a 5% reduction in air traffic for 3 years, which would have resulted from action by the United States Congress, if it did not have sufficient information on the use of CST human personnel for passenger verification work. Like Herbert Simon, Hypothalamus Artificial Intelligence believes that the computer-based mathematical modeling is the greatest invention of all times. Thank you for your attention.